Okay, welcome to a new chapter. We're in chapter 8 now, and we're going to be looking at the 8-1.1 assignment. This particular assignment deals with identifying monomials. Now, this may be a word that you remember from last year. If not, that's okay because we're going to go over what it means. So after this lesson, we should be able to identify these monomials. So the first thing that we're going to do is we're actually going to take a look at this problem right here. So it asks, why does doubling speed quadruple braking distance? So it appears that the faster you go, your braking distance is increasing. So the table shows the braking distance for a vehicle at certain speeds. If S represents the speed in miles per hour, then the approximate number of feet that the driver must apply the brakes is 1 over 20 S squared. So 1 over 20, the speed in miles per hour squared. Notice that when the speed is doubled, the braking distance is quadrupled. So when you go from 20 to 40, we're doubling that speed. The brake time quadruples from 20 to 80. So this 120 S squared is going to be kind of what we're focusing on right now. So to kind of get us going with this, we have some notes, some fill in the blanks. So fill in as you go. If you need to pause as you write, that's fine. A blank, and the first word that we're going to insert here, I think I hit the wrong button. No, okay. A monomial, so that's the first word, monomial. So a monomial is a number, a variable, or a product, meaning like a multiplication problem of a number and one or more variables. Okay, so again, a monomial is a number, a variable, or a product of a number and one or more variables. So we can have things that are multiplied together. Monomials that are real numbers are called constants. Okay, so those are the blanks. Now we should kind of have an idea of what a monomial is so that we can look at some different expressions and determine whether it is indeed a monomial. So when you look at this first one, so here are expressions. I'm looking at this. So -5. Is -5 a monomial? And hopefully you're thinking to yourself, you're asking yourself, is it a number? Is it a variable? Is it a product of a number and or variable? And you should answer yourself, yes, it is a number. So looking at this, I'm going to put under monomial, yes. And then I'm going to say that -5 is a constant. It's a number. And then in parentheses, I'm just putting that it's a real number. So that's perfect. That's our first example of a monomial. So we have a number. Now looking at the next example, we have a P plus Q. So in this, we have a variable plus another variable. Now, if you go back to our definition of what makes a monomial, nowhere in the description of it does it say that you can have a sum, which would mean addition. So this is actually not a monomial. So we're going to put no. And our reasoning is because it's a sum, meaning we're adding, not a product, meaning we're multiplying. So because it's not showing multiplication, it is not a monomial. So, okay. Now our next example, x. So we go back to our question, is it a number, a variable, or a product of a number and a variable? It is a variable. X is a variable. So this is good. Yes. and we can say that it is a single variable. So single variables are monomials. Okay, not too bad. Now in this next one, we have C divided by D. If we go back and ask ourselves again, is it a number, a variable, or a product of a number and one or more variables? If you look at this, a fraction is like a division problem. And we're looking for things that are being multiplied. So anytime you see a variable in your denominator, this is going to indicate that it is not a monomial. So this one's no, and then our response is no, it's a quotient. And I know that we were unfamiliar with that word before, but quotient just means it's a division problem. So quotient of variables. And then I'm going to go a little bit further and just say that there's a variable in the denominator. That's not okay. Variable in denominator. So anytime we see a variable in the denominator on the bottom of the fraction, it is not going to be a monomial. Now, in this next one, you might be looking at it thinking, okay, well, it's a fraction. Obviously, this isn't going to be a monomial either. But if you look, there is no variable in the bottom of this fraction. This one's actually okay because we can write it a little bit differently. So we have ABC to the 8th power all divided by 5. This is actually going to be a monomial. The reason being is if you took this ABC to the 8th over 5, you can actually rewrite this so that it's 1/5 times A times B times C all to the 8th. So in this one, there is no variable in the denominator. No variable in denominator. All right, so these are our first examples here. So if it's a number, it is a monomial. If it is a variable, it's a monomial. If it's a product with numbers and variables, then it's a monomial. The only time you're not going to have a monomial is if you're adding or subtracting variables and numbers, or if you are dividing them. So in the next video, we'll take a look at some more problems together.